the next topic is static error constant. The next topic is static error constants. Okay, so here static error constants means, so when the control system is excited with standard input signal, the steady state error may be 0, constant or infinity. Okay, you just see that when a control system, this is the control system, when this control system is excited with standard input signal, so means standard input signal I told you is a step signal or parabolic signal, ramp signal. This is a parabolic signal, impulse signal. So when your control system is excited with this type of input signal, the steady state error, this is the steady state error. The steady state error may be 0, may be constant, may be infinity. So these are the three possible steady state error when your control system is subjected to standard input signal. Okay, now the value of steady state error depends on the type number of the system. So you see that here the value of steady state, here the value of steady state error, the steady state error depends on the type number and the input signal. What is the type number? So see what is the type 0 system, type 1 system, type 2 system, right? And what is the input signal? Okay, if you just see, if your control system is type 0 system, type 0 system, and our input signal is step signal, so the error, steady state error depends upon type number and its input signal. Here some example given here. So type 0 system will have a constant steady state error. It means when this type 0 system is subjected to input step signal, so your steady state error would be constant. That's a constant steady state error. Okay, next type 1 system, when type 1 system will have a constant steady state error when the input is ramp signal. Okay, so when your type 1 system is subjected to ramp signal, so your steady state error would be a constant. Yes is a constant. Okay, yes is a constant. So when for type 2 system is subjected to parabolic signal, so you will have a constant steady state error. So for these cases mentioned above, okay, for all the cases mentioned above, means type 0 system is subjected to step signal, then your steady state error is a constant. When type 1 system is subjected to input, that is a ramp signal, you will have a constant steady state error. When type 2 system is subjected to parabolic signal, accelerated signal, so you would have steady state error constant. For all above these three cases, all right, so the steady state error is associated with one of the constant defined as follows. Okay, you see that here this for the constants here, these are the steady state error constants. Well, first one is the position error constant. So that is a Kp is equal to limit s tends to 0 g of s into h of s. Okay, next velocity error constant, the Kv is equal to limit s tends to 0 s into g of s into h of s. This g of s and h of s is a loop transfer function. Then acceleration error constant, that we are going to represent as a Ka. It's a limit s square g of s into h of s. Okay, so once again I repeat, this is the position error constant, so we represent as a Kp, right? So you can easily remember P stands here position, position error constant. P stands position, so we can remember easily. It's a position error constant is equal to limit s tends to 0 g of s into h of s. Here s power 0, s power 0 means 1. So now kv, so this is a v stands velocity error constant, limit s tends to 0 s into g of s into h of s. Okay, next acceleration error constant, that is a ka, limit s tends to 0. So here E of s, ESS steady state error is equal to limit s tends to 0 s into r of s 1 plus g of s into h of s. Okay, here so r of s, here r of s is input signal, r of s is here unit step signal. So this is actually r of s is the input signal. Okay, when the input is into step signal, that is r of s is equal to 1 by s. So what is the steady state error? The steady state error is limit s tends to 0, so s into r of s by 1 plus g of s into h of s. Okay, h of s. Okay, so here your r of s is 1 by, substitute here r of s, substitute here, what you get when you substitute r of s is equal to 1 by s, you will get so this is E of s is equal to limit s tends to 0. Okay, so s into r of s is equal to 1 by s, r of s is equal to 1 by s, so 1 by s by 1 plus g of s into h of s. So here s gets cancelled, so you will get limit s tends to 0 1 by 1 plus g of s into h of s. Okay, so ESS is equal to limit s tends to 0 1 by 1 plus gs into hs. Okay, so take the next slide. So what you got here? So you got E of ss ASS is equal to limit s tends to 0, so that is 1 by 1 plus g of s into h of s, g of s into h of s. Now you multiplied inside limit s tends to 0. If you multiplied, so you will get 1 by 1 plus limit s tends to 0 g of s into h of s into h of s. So you know that limit s tends to 0, so that is s power 0 g of s into h of s is equal to kp. Okay, that is a proportional error constant. Kp is equal to limit s tends to 0, so g of s into h of s. You substitute in this equation, so what you get now? Error ESS is equal to limit s tends to 0. Okay, when you multiply inside, so 1 by, so this is a 1 plus, so g of s into h of s. Okay, you know this value, you substitute in this equation, so you will get ESS is equal to 1 by 1 plus that is kp. Okay, so your steady state error is 1 by 1 plus kp. So here the kp is a positional error constant. I have already given you the kp is equal to, kp is positional error constant. Okay, so when your system is subjected to unit step signal, you got steady state error is what? 1 by 1 plus kp. For example, if you just see that your system is like this, so your system is subjected to some type of, this is a step signal, so you get this type of response. Okay, you get this type of response. Now what is your steady state error? What is steady state error? So your steady state error, is ESS is equal to 1 by 1 plus kp. So this is a steady state error. So now we see that type 0 system, what is the steady state error? So we will take here type 0 system. Okay, so then what, when the type 0 system is subjected to step signal, so what is the steady state error we are going to get? So type 0 system, you know that kp is equal to limit s tends to 0 g of s into h of s. Okay, and also we can write this one, limit s tends to 0. So what is this value? G into g of s and h of s, that is k into s plus z1 s plus z2 so on by, right? So s plus p1 s plus p2. This is a type 0 system because here s power is n is equal to 0. Okay, so now you substitute limit s tends to 0. So what happened here? K by, so you will get k into, so you substitute s is equal to 0, you will get z1 z2 z3 so on, and p1, okay, p2 p3. Here what happened, you substitute all the s values, so you will get this constant. Okay, see, this is z1 into z2, this is a constant into constant by constant, you will get constant term, so you will get constant. So ESS is equal to 1 by 1 plus kp is equal to constant for type 0 system. What happened? Error is here constant. Hence in this type 0 system, in type 0 systems, when the input is unit step, there will be constant steady state error. So I am going to write here, hence in type 0 systems, when input is unit step, there will be a constant steady state error. Okay, now we see for type 1 systems. Okay, type 1 systems, type 1 system. So for the type 1 system, so you know the equation, that's a proportional error constant. So kp is equal to limit s tends to 0. Okay, so that is g of s into h of s, So you know that limit s tends to 0. So here g of s into h of s means, so that is s into s plus z1 s plus z2, okay, so on, s plus z3 so on, like this. Then so s plus p1. Okay, so of course here is the s. Okay, since is a 1 is power is 1, n is equal to 1, so type 1 system. So s plus p2 and so on, s plus p3, like this. Okay, so now you substitute s is equal to infinity, so here won't be there. Yes, it is a k, so g of s into h of s is equal to s plus z1 into s plus z2 by s into s plus p1 s plus p2. We substitute s is equal to 0, so what happened when you substitute s is equal to 0, so you will get, so what happened here, z1 z2 so on. Okay, this is a constant, so you substitute 0, so p1 into p2 so on. So what happened if you multiply this 0? Okay, this will be a constant. Okay, this is a constant, so k is a constant, z1 z2 also constant by 0, so anything b by 0 is a infinity. So here your proportional constant, okay, is infinity. Proportional constant is infinity. So what is your steady state error? Your steady state error is here 1 by 1 plus kp. So in place of kp, if you substitute infinity, 1 plus infinity, so you will get 0. 1 plus infinity, so 1 plus infinity is infinity, 1 by infinity is 0. Okay, now your steady state error is 0 for type 1 system. So type 0, once again I will explain you. So type 0 system, what is your kp? Kp is equal to limit s tends to 0, okay, g of s into h of s. Here limit s tends to 0, k s plus z1 s plus z2 by s plus p1 p2. Here is power is 0 here, right? Here is power is 0. Okay, so when you substitute s is equal to 0, so what happened? So this become constant. So you got kp is here, kp is constant, kp is constant. Okay, so what is steady state error? Steady state error, you know, steady state error is equal to 1 by 1 plus kp. So if we put in place of kp here the constant 1 by 1 plus constant, 1 is a constant, this is a constant value. Okay, constant plus constant is equal to constant, 1 by constant is equal to constant. So steady state error you will get the constant for type 0 system. For a type 1 systems, so your steady state error is 0. Your steady state error is 0. So the same, like if you find steady state error type 2 system, type 3 systems, type 4 systems, so your steady state error will be 0. So what the final conclusion here, in systems with type 1 and above, for unit step input, the value of kp so is infinity, and so the steady state error is 0. Steady state error 0. It means if you take a type 2 system, what is the type 2 system? If you take limit your kp proportional error constant simply s tends to 0, so you got type 1. Now type 2 system, so type 2 system also we find, so you will get the error is 0, you will get. Okay, so we are going to get, see type 2 system here, this is a type 2 system 0. So type 2 system means here, so g of s into h of s. Okay, so what is our kp? Kp is equal to limit s tends to 0. Type 2 system means here 1 by s square. Type 2 system means G of s means s plus z1, so s plus z2, so on, s plus p1, s plus p2, and so on. Okay, so your kp is equal to, substitute s is equal to 0. What happened? So z1, of course k is there, k into here z1 z2 by s square means 0 square p1 into p2. So what happened? This is a constant by 0, it's infinity. So kp value is equal to infinity. So you know what is the steady state error? So 1 by 1 plus kp. So what is the kp here? Kp is equal to this is a infinity. So you will get 1 by infinity, that will be 0. So steady state error is 0. So type 2 system, type 1 system also steady state, type 2 system also 0. So type 3 system also you will get error is 0. That's what. So the final conclusion here, in system with the type 1 and above, first step input, the value of kp is infinity and the error is 0. See, type 2 system also infinity, so error is 0. If you just take type 3 system, what happened? In kp value you will get infinity and your error is 0. If you take type 4 system, so you will get kp value is infinity, so you will get steady state error is 0. Okay, so next we are going to study So next what we are going to study? Now we are going to study steady state error when the input is unit ramp signal. So previously we have studied steady state error when the input is step signal. Now we are going to study steady state error. Steady state error. So when the input is unit ramp signal, okay. So we're going to study the steady state error when the input is unit step signal. So last class what we have done, so in the last topic, so last subtopic, steady state error when the input is step signal. So when the input is step signal, so you got the steady state error, so ess is equal to 1 by 1 plus kp. Okay, so you found the proportional constant. So what is the proportional constant? kp you got for time 0 system, so you got kp is equal to constant and the steady state error is constant. Type 1 also, so you got kp is equal to infinity, the steady state error is infinity. And about type 1 system, so you got steady state error is so it's 0. Okay, so now steady state error when the input is unit ramp signal. So we see that. So what is steady state error equation? The steady state error, steady state error, ess is equal to, steady state error ess is equal to limit s tends to 0, right, s into r of s by 1 plus g of s into h of s. You know this equation. Okay, so this error ess is equal to limit s tends to 0, s into r of s by 1 plus g of s into h of s. Here when the input is unit ramp signal. Okay, so here R of s is equal to inward ramp signal. So R of s is equal to what? 1 by s square. So 1 by s square. So we substitute here. So ESS is equal to limit s tends to 0. So s into R of s means 1 by s square by 1 plus g of s into h of s. So 1 s gets cancelled. So you will get limit s tends to 0. Limit s tends to 0. So just you 1 by s, okay, by 1 plus g of s into h of s. Now what I am going to do this limit, so that is steady state error, limit s tends to 0, okay, so 1 by s into 1 plus g of s into h of s, g of s into h of s. You just multiply limit inside. So what you get when you substitute lim s tends to multiply s tends to 0, s tends to 0, okay, s plus limit s tends to 0, okay, so s into g of s into h of s. I multiplied limit s tends to 0 and also s I multiplied inside. So ESS is equal to 1 by, so this becomes 0. So you know limit s tends to 0, s into g of s into h of s is equal to, that is velocity constant. You know that kv is equal to limit s tends to 0, okay, s into, so g of s into h of s. So that is you this value, you know. So I am going to put here in this place, I am going to substitute kv. So your steady state error is equal to 1 by kv, 1 by kv, okay. So here the constant kv is called velocity error constant. Here the kv is called velocity error constant. So now for type 0 system, okay, we take type 0 system, type 0 system, we find it kv is equal to so you know that limit s tends to 0, s into g of s into h of s, okay. So now we substitute here. So limit s tends to 0, okay, s into s plus z1, s plus z2, okay, by p plus s plus p1, s plus p2 and so on, okay. So kv is equal to here. So when you substitute s is equal to 0, you will get 0 into z1, 0 into z2, z3, so on here, and p1 into p2 into p3, okay, so on. So what happened, 0 by constant, p1 p2 3 constant, a constant, so you will get 0. So kv is equal to, now you got the 0. So for type 0 system, your proportional your velocity error constant is 0, then what is steady state error? So what is steady state error? So your steady state error is equal to ESS is equal to, so 1 by kv, you got 1 by kv. So what is the kv here? Kv is equal to 0, so you will get infinity. Kv is equal to infinity. So the steady state error is infinity. It means steady state error means it's infinite. The error is here. So this is a infinite error, you got it, okay. So that's a type 0 system. So we see that type 1 system, what happens, okay. So you can write the conclusion here. I am going to write the conclusion. Hence in type 0 system, when the input is when the input is unit ramp, the steady state error, the ESS, the steady state error is infinity. The steady state error is infinity. Okay. Now type 1 system, we see that type 1 systems. Type 1 system. So for type 1 system, you know that kV is equal to limit s tends to 0, okay, s into g of s into h of s. Okay. So limit s tends to 0. So what is your g of s into h of s? So that is k into s plus z1 s plus z2 so on. So s plus p1 s plus p2, okay, and here yes. Okay. So type 1 system, this one for the type 1 system, so this is this value become, so k into s plus z1 s plus z2 by s into s plus p1 into s plus p2. Okay, now s gets cancelled and you substitute s is equal to 0, so you will get so you will get k into, okay, into so z1 z2 z3 by p1 into p2 into p3. So you will get constant. So for type 1 system, so kV is equal to constant. So now what is steady state error? S is equal to 1 by kV is equal to, kV is a constant, so you will also get constant. Therefore ESS is equal to constant. The steady state error is here constant. So when type 1 system is subjected to unit ramp signal, so your system will have so constant steady state error. So I am going to write the conclusion here. Hence in type 1 system in type 1 system, when the input is unit ramp, there will be a constant steady state error. There will be a constant steady state error. So we see type 2 systems also. Type 2 system. So what is the kV? kV is equal to, so here limit s tends to 0, s into g of s into h of s, g of s into h of s. Now our system is type 2 system. Okay. Now our system is type 2 system. You know what is the type 2 system equation? kV is equal to limit s tends to 0, s. Okay. Type 2 system means k into s plus z1, s plus z2 so on, s plus z3 so on, like this, by s into, okay, s into s plus p1, s plus p2 so on. So now this s gets cancelled, so your kV is equal to limit s tends to 0, so k into, so s plus z1, s plus z2 by s plus p1, s plus p2 so on, like this. Substitute s is equal to 0, you will get k into z1 z2 so on, p1 p2. So what happened? Constant into constant by constant, so you will get constant, the constant. So what happened? kV is equal to here constant. So what is your steady state error? Your steady state error is equal to 1 by kV. Okay, 1 by kV. Right. So kV you substitute constant. So what happened? 1 by constant is equal to constant. So your steady state error is equal to constant. So when type 1 system is subjected to unit ramp signal, so you got a system got constant steady state error. Okay, so see now what happen if we just apply type 3 system also. So type 3 system also you will get here type 3 system also, what your error is constant. Your error is constant. Okay, and also here so next we find type 2 system. For type 2 system, what is the steady state error? So we take the type this is a type 2 system. So for type 2 system, so what is the kV? What is the kV? So kV is equal to limit, you know that kV is equal to limit s tends to 0, right? S into g of s into h of s. So you know this. Okay, so now kV is equal to limit s tends to 0, yes. So your system is type 2 system. So type 2 system means g of s into h of s. Type 2 system is k into s plus z1, s plus z2, okay, s plus z3, so on, by, since this is type 2 system, you will get here s square. You will get s square here. So s plus p1, so s plus p2, so on. Okay. Now kV is equal to if you just here s gets cancelled, so you will get limit s tends to 0, okay, and k into s plus z1, okay, s plus z2, so on, by s into s plus p1, s plus p2, so on. So when substitute s is equal to 0, so what do you get? So k into z1, z2, so on, by 0 into p1 into p2, so on. So you will get infinity. So kV is equal to infinity. kV is equal to infinity. What is steady state error? Steady state error is equal to 1 by kV. So we substitute infinity. So 1 by infinity is 0. Therefore steady state error is equal to infinity for type 2 systems. Okay, so if you find a type 3 system also and a type 2 system and above, it means type 3 system, type 4 system. So when this all above type 2 systems and type 2 system is subjected to ramp input signal, so the kV would be infinity, so steady state error is 0. So I'm going to write here, so type 2 and above for unit ramp, so the value of kV is infinity, so the steady state error is 0. Okay, so next we are going to study steady state error when our input is parabolic signal. When input is a parabolic signal, we see that the heading you can write steady state error when input is a parabolic signal. parabolic signal. Okay, you know that the steady state error, so that is ESS. Okay, ESS is equal to limit s tends to 0. Okay, 1 s into rs by 1 plus gs into hs. Okay, this equation you know very well. ESS is equal to, okay, ESS is equal to, so when your input is, so I am going to write again our steady state error ESS is equal to limit s tends to 0. Okay, s into r of s by 1 plus g of s into h of s, g of s into h of s. So here when the input is unit parabolic, when the input is unit parabolic signal, input is parabolic, unit parabolic signal, so this r of s become now 1 by s cubed, 1 by s cubed. Now substitute this one, so ESS is equal to limit s tends to 0, right, s into r of s is equal to 1 by s cube, so s square, s by s into r of s is equal to 1 by s cube by 1 plus g of s into h of s. So what happened here, ESS gets cancelled, so you will have limit s tends to 0 1 by s square plus limit s tends to 0, limit s tends to 0, so this is g of s into h of, g of s into h of s, g of s into h of s. So I am going to write it here, and finally limit, so E steady state error limit s tends to 0 1 by s square plus, so limit s tends to 0 s square, so g of s into h of s. Okay, so here, and I am going to send limit s tends to 0 also here, so I am supposed to write like this, ESS is equal to 1 by limit s tends to 0 s square plus limit s tends to 0 s square g of s into h of s. I am supposed to write like this, but I have made mistake here. So now ESS is equal to, so if we send the limit, substitute s is equal to 0, what happened is this is 0 square plus, so this value you know, this is Ka in the acceleration error constant. Ka is equal to, you know, acceleration error constant, acceleration error constant, that is a Ka. So I am going to substitute here Ka. So 1 by 0 plus Ka is equal to 1 by Ka. So so when your system is subjected to step parabolic signal, so the error is 1 by Ka. So we find what is, for the type 0 system, what is the acceleration error constant and what is the steady state error. So we are going to find it. Okay, so when you see this here, type 0 system, type 0 system, what is the Ka? Ka is equal to limit s tends to 0, okay, s square g of s into h of s. So you know what is the type 0 system, you have to substitute here type 0 system equation. Okay, So what is type 0 system equation? Type 0 system equation is Ka is equal to limit s tends to 0 s square. Type 0 means k into, okay, s plus z1, okay, and s plus z2, so on, by type 0 system means here only 0 will come here, okay, s plus p1, s plus p2, and so on. So when you substitute s is equal to 0, so what happened? So this 0 into z1, z2, so on, by p1 into p2 into, so 0 by anything, 0 by constant is 0. So your k acceleration error constant is Ka is equal to here 0 for type 0 system. So what is our steady state error? Steady state error is equal to 1 by Ka. So Ka is equal to 0, so you will get, but steady state error is equal to here infinity. Steady state error is infinity. So we find a type 1 system also. Type 1 system. So we take the type 1 system. So type 1 system, what is a Ka? Ka is equal to limit s tends to 0 s square, okay, g of s into h of s. Ka is equal to limit s tends to 0 s square g of s into 7. So now your system is type 1 system. So what is the type 1 system equation? Ka is equal to limit s tends to 0 s square. So type 1 system, so what is that? K into s plus z1, s plus z2, so on, by s, okay. Here this is type 1 system, okay. Type 1 system, s plus p1 and s plus p2 and so on, okay. So Ka is equal to, now if see this s and this s gets cancelled, means here one s is left. So limit s tends to 0 s into k s plus z1 s plus z2 by s plus p1, okay, s plus p2 and so on. So when you substitute s tends to 0, what do you get? When you substitute s tends to 0, so you will get, so 0 into substitute s is equal to 0 here. Here also s is equal to 0, 0. So z1, z2, so on, by p1, p2, so on. Okay, of course, is a k is there. So 0 by constant is, it is a 0. 0 by anything is 0. So here a Ka is equal to 0. Ka is equal to 0. So what is the steady state error? What is steady state error? So you will get the steady state error. Steady state error ESS is equal to 1 by Ka. So what is the Ka? You got Ka is equal to 0. So your steady state error is infinity for type 1 system. Okay. When type 1 system is subjected to steady state, subjected to parabolic signal, so you get steady state error is infinity. Okay. So what is the final conclusion here? I am going to make it. So here, so for type 1 system, so your acceleration error constant is 0, therefore your steady state error is infinity. Okay. So what is the final the conclusion I can write here? Okay. Hence type 1 system for unit parabolic input, the steady state error is infinity. The steady state error is infinity. Okay. When you take type 2 system, so what is the Ka? Ka is equal to limit, this is a acceleration error constant, s tends to 0, so s square and g of s into h of s. So now your system is type 2 system. Okay. Type 2 system means Ka limit s tends to 0 s square k into s plus z1. This is type 2 system, s plus z2 so on. So s square is there, s square. Type 2 system is s square. Okay, s plus p1, s plus p2, so on like this. Okay, so what happens, s square gets cancelled, so you left only with the limit s tends to 0, okay, k into s plus z1, okay, s plus z2 so on by s plus p1, s plus p2 and so on. So Ka is equal to, when you substitute s is equal to 0, you will get k into z1 z2 by p1 p2. So your error is, your proportional acceleration error constant is a constant. So Ka is equal to here constant. Ka is equal to constant. What is steady state error? ESS is equal to 1 by Ka. So Ka means here constant. So you will get constant. So therefore ESS is equal, steady state error is equal to constant. Steady state error is equal to here constant. So when type 2 system, okay, subject to step parabolic signal, unit parabolic signal, so you will get the Ka acceleration error constant is Ka is equal to constant. Okay, and your steady state error also you will get constant. So here type 2 system, okay, so you got your steady state error is a constant. Now we will check with the type 3 system. So type 3 system, so what is that? Ka is equal to, limit s tends to 0 s square g of s into h of s. Okay, Ka is equal to limit s tends to 0. Okay, so this is now type 3 system. So type 3 system, how it would be? K into s plus z1, okay, s plus z2 so on by, since it is a type 3 system, you will get s cubed here, so s plus p1, so s plus p2 and so on. So here s square, here s cubed is there, so s square gets cancelled, left s is left here. Okay, so I am going to write Ka is equal to limit s tends to 0 k s plus z1 s plus z2 so on by s into s plus p1 s plus p2 so on. So Ka is equal to, substitute s is equal to 0, limit s tends to 0 k into z1 z2 by so on, so 0 into p1 p2. So what happened, this is a constant, above is a constant by 0, so it will be infinity. So Ka is equal to now infinity. So what is steady state error is equal to 1 by Ka is equal to, when you substitute infinity, so you will get 0. Therefore the steady state error is 0. For type 3 system, acceleration error constant is 0, infinity, s infinity here, Ka infinity, and our steady state error is 0. Okay, and here the conclusion is that type 3 and above, so what happened, for unit parabolic input, the value of Ka is infinity and steady state error is 0. I am just writing here, in systems with type 3 and above for unit parabolic input, the value of Ka is infinity. Okay, and the steady state error is 0. Means type 4 same you will get. For type 4 Ka is equal to infinity and if steady state error is 0. Type 5 also the same thing, so it will go on. Okay, so now I just make a table here for static error constant for various type number of systems, and also steady state error for various types of input. Okay, so I make a table here so that it would be very easy. Okay, so two tables I am going to explain you. One is the steady state error constants for various type of various type number system, and another one is steady state error for various type of inputs. Okay, so static here, static error constants, static error constant for various type number of systems. Okay, so you see that I'm going to make a table here. So first here, so first this is the type number, of system. Okay, and here this is error constant, error constant. Okay, so what are the error constant we have? We have error constant kp. Okay, and another one is the kv, another one is the ka. Okay, so we'll just take only 3 systems. Here type 0 system, here type 1 system, here type 2 system, here type 3 systems. Okay, for type 0 system, what is the kp value? Type 1 system, what is the, all things we'll see. Yeah, okay, I'm going to make a table. So this table is very important. Okay, you see that here, once again I want to explain this table. Here is the, in this row, steady state, error constant or kp, proportional error constant, velocity error constant, acceleration error constant. In this here, in this row, so type number of system. So here type 0 system, type 1 system, type 2 system, and type 3 system. So type 0 system, what is the kp? It's a constant. Okay, we already derived this. So for a type 1 system, what is the kp? Infinity. Okay, and a type 2 also infinity, and type 3 also infinity. So when you take error constant ka for a type 0 system, it is a 0. For a type 1 system, it is a constant. Okay, and a type 2 infinity, and a type 3 also the kv is infinity. Okay, and the ka for type 0 is 0, and type 1 is 0, type 2 is constant, and type 3 is infinity. Okay, you just understand this diagram. Okay, so this, in this column is error constant kp, kv, ka. In this row, type number of system, this means 0, 1, 2, 3, type 0, type 1, type 2, type 3. So kp. So for type 0 system, what is the proportional constant? For type 0 system, the proportional constant is, so constant. Type 1 is, the kp is infinity, and type 2 also kp is infinite. Type 3 system also proportional constant is infinity. Same like a velocity constant. For type 0 system 0, and type 1 system constant, type 2 system infinity, type 3 system infinity. For acceleration constant, for a type 0 system it is 0, type 1 system is 0, and type 2 the acceleration constant is a constant, and next is the type 3 system, the acceleration constant is infinity. Okay, this is the table 1. So table 1. Okay, so next to table 2 we are going to see table 2. In the table 2, steady state error for various types of input. Okay, steady state error for various type of inputs. Same like before, you can make a this table and we can find it. Okay, so in the column I'm going to take as input signal. In the row I'm going to take as a type number, same like this like before. So here input signal. So here this is type number of system. So here, okay, so this is a 0 system, this type 0 system, 1 system, type 2 system, type 3 system. Okay, so I'm going to make it another 3 rows. This is unit step signal. This is unit ramp signal. So this is unit ramp. So this is unit parabolic signal. This is unit parabolic signal. So when unit step signal is subject to a type 0 system, so you will get so your steady state error means 1 by 1 plus kp. Okay, so that is 0, next 0, 0, 0. So your steady state error is 0. Type 1 system, type 2 system is 0, and type 3 system is, and ramp signal, so that's infinity. So 1 by kV, steady state error is 1 by kV, and 0 and 0. Here parabolic signal, so it is type 0 system, steady state error is infinity. Here also infinity, 1 by Ka, it is 0. So I'll tell you, explain once again. So in this column, input signal, unit step signal, unit ramp signal, unit parabolic signal. Here is the type number of system: 0 system, type 0 system, type 1 system, type 2 system, type 3 system. So when your type 0 system is subject to input unit step signal, so your steady state error is 1 by 1 plus kp. But for type 1 system, ESS is 0, type 2 system 0, type 3 system is 0. It means steady state error is 0. Likewise, ramp signal and unit parabolic signal.